Welcome back to Mr. Slover's Math. Today we're going to learn about combining like terms. So this top part in the warm-up is just you seeing if you might know what a like term is already. So if you didn't circle any of those, not a big deal. I didn't teach you anything yet. All right, here's where we get into like terms. So like terms have the same variable along with corresponding variable having the same exponent. Pretty much means that if it's the same letter and power, we can go ahead and combine them. So here's an example, 4x squared plus negative 12x squared. They have the same letter, x and x, the same variable in common, and they both have a power of 2, so x squared. It does not matter what the coefficient is. So this coefficient is 4. Remember, the coefficient is the number in front of the variable. This coefficient is negative 12. It does not matter what the coefficient is. So example 1 says, circle any expression that has like terms. So the first one is no, because they're different letters. X is not the same letter as Y. The second one, they both have the letter X and it's to the fourth power. So we're going to circle those. The next one, they do both have the letter M, but one has just M and the other has M cubed. They are not the same power. Okay, same letter, yeah, but it has to be both the same letter and the same power. Now the next one, you're thinking, well, why did Mr. Slover circle that one? There's no letters in there. Well, these are both constants. 15.3 and 27.1 are both constants, which means there's just a number. There's no variable with it. Those are always going to be like terms. So anytime you see 2, 3, 4, or 5 constants, those are all like terms. Think about when we went through the order of operations a few days ago with our PEMDAS. Those were all like terms. They were all constants. And then the last one, negative 5y minus y, they are the same letter and the same power. When we combine like terms, so that's what we're going to do in example 2, we're going to combine them, but we do not change our exponents or power. We're just changing the coefficient. So in example 2, in all of these, I went through and I highlighted the like terms, okay, which means the same letter and the same power. It has to be both. So this says 17u plus 25u. I add the coefficient of 17 plus 25 and I got 42. And I still have the letter u. For letter B, yes, they all have a t, but only 2 of them, these 2, have a t to the first power. 6t squared, there's no other t squareds in there, so that number, that term drops straight down. And then we combine this. 6 minus 1 gave me 5t. So over here, I don't have any a's. Well, you're thinking, well, that's an a right there, but that says a squared. That's not the same as just a. Same letter, yes, but it has to be the same letter and the same power. So this one has nothing in common. There's no like term, so you just rewrite the expression. That's it. Just like in this one, I rewrote the expression. Now, if you wrote y minus 13k, that's fine. If you wrote negative 13k plus y, that's fine. It doesn't matter. Letter E, same letter, x and x, same power, squared. So it says negative 1 minus 1. If you're not good with negatives, use your calculator. Do negative 1 minus 1. Or if you want to try it, do mental math. Think I owe someone $1 and I owe them another $1. How many dollars do I owe them? 2. So you're in debt, $2, negative 2. And then down here, this is example 3. It's just asking you to create your own example. So it says it has 3 terms. So 1, 2, 3. And it has terms that you can combine. So I can combine this one and this one. Same letter, same power. 7 plus -8 is -1. I still have the x to the fourth, and the -1 is still there because there was nothing that I could do to it. Okay, so if you're combining like terms, you have to have the same letter